Hello everyone and welcome to this KubeCon Container Day session on, we're going to talk about AWS Inferentia running on Amazon EKS. My name is Mike Stefaniak. I'm one of the product managers on EKS that's been focusing on machine learning. EKS just turned 2 years old as a generally available service, so happy birthday EKS. If you had asked us, 2 years ago, would machine learning have been such a large use case, we probably would have been surprised. But it turns out, for a reason we'll get to here in a minute, it's actually one of the largest use cases running on Amazon EKS today. So we're going to cover why. Why is it such a use case quickly? We're going to go over AWS Inferentia and the EC2 Inf1 instances that run them. And then we're going to go over how we integrated those instance types into EKS. So first of all, why machine learning on Amazon EKS? And I think before you get to EKS and Kubernetes, you really need to talk about containers. Containers solved the problem of it runs on my machine, but not here. And it turns out that problem is even more pronounced with machine learning. If you look at some of the list of libraries here, SciPy, NumPy, Pandas, Python, these GPU libraries, there's a bunch of different libraries that machine learning practitioners are going to have in their applications. And containers really help making them portable, where you can run it on your machine locally and then ship it off to the cloud to take advantage of the computing power there. So really some of the same problems that containers solved are being solved in the machine learning space as well. And then why Kubernetes? We see three main reasons why it's become such a big use case on Kubernetes and EKS. One is composability. We'll get to a slide in a minute that shows the different sections of machine learning, but you can have data ingestion, data analysis, training, validation, inference, and each of those steps really ends up being a microservice. And Kubernetes turns out to be a great place for scaling and orchestrating microservice container-based applications. Next is portability. Like we mentioned, you can run your Kubernetes cluster locally, run your inferencing there for testing, and then bring it to the cloud. And then really the last point is scalability. When you're running in the AWS cloud, you have the power of a bunch of EC2 instances that you can scale out very easily using a Kubernetes cluster. So we've seen those three reasons why it's become so popular. And then when you look at EKS, we see the machine learning stack really in three different layers. At the bottom are the frameworks and the infrastructure. So you have your popular frameworks like TensorFlow and MXNet and PyTorch, and then you have your infrastructure like the P3 instances for training, G4 instances, FSX for Lustre for distributed storage, and then today we're going to talk about Inferentia, which is our new custom-built EC2 instance for inferencing. Then at the container layer, you have things like the accelerated AMI that we have for EKS, deep learning containers, auto-scaling, the CSI plugin, and then at the top layer are the different platforms. So Kubeflow is a popular platform that runs, and then different enterprise tools that also run. And so I mentioned before the slide on the different sections of the ML workflow. There's a bunch of different steps. People generally think about just the training section when you think about machine learning, but it's actually a lot of different steps, which includes data preparation, development and training, and then deploying the model in inferencing. And today, we're going to talk about serving. And it actually turns out that when you look at training versus inference, models are becoming ever more complex. We've seen more and more models like BERT and these other natural language processing models become more complicated, and the cost to run those models in production becomes higher and higher, and it can become out of reach for a lot of organizations to run that at scale. And when we dug deeper, it turns out that the training can be less than 10% of the cost, but inferencing can account for over 90% of the costs. Because you might train a model once a week for a few hours, but if you have some fraud detection service running, that's running 24/7. And so it turns out that the bulk of the costs for machine learning end up being in inferencing. And so in order to solve that low-cost inferencing problem scale, at AWS we decided to build a custom-built chip to address this problem. And that's what we've called AWS Inferentia, which was released at last year's reInvent, and we recently added support for EKS. So we'll quickly cover what AWS Inferentia is, EC2 Inf1 instances, which run the Inferentia chips, and then AWS Neuron, which was the SDK that we built to run along with Inferentia. So let's start with the Inferentia chip. We solved Inferentia really to design one problem really well, which is inferencing at scale. Each Inferentia chip can provide more than 100 tera operations per second at low power, which allows us to pack a lot of these chips into a single instance. And each Inferentia chip has 4 of what we call neuron cores, which is a high-performance systolic array matrix multiply engine, which is the type of operations that a machine learning model is doing behind the scenes. And each one of these cores has a large on-memory cache, which allows us to load more of the model into memory so you're not reading it from disk and you get faster performance. We also have a fast interconnect technology that allows us to do really quick networking between each of the cores. And so that allows for inferencing at scale where you're not having networking as the bottleneck. And we've also released what we call the Inf1 instance family. And this is the instance family that runs the Inferentia chips. So we have 4 different sizes of the Inf1 instance family with 1 chip all the way up to, I believe, 8 chips. And each of the instances includes AWS Inferentia. It's also built on AWS Nitro, which is our custom-built hypervisor. And like I mentioned, the fast networking. So you get up to 100 gigabytes per second networking. So it's high performance, low cost. And we'll show some details here. These were tests we ran. These weren't a benchmarking test in a synthetic lab just to showcase hardware capability. These were real life examples. And in the top case, we used a BERT, which is a natural language understanding model. The test was running using TensorFlow serving, and we compared Inf1 instance performance against G4 instance performance. G4 was already the best price to performance instant option in the cloud. And as you can see from this data here, we significantly improved on the price to performance and cost per inference you get with Inf1 compared to G4. So 40 to 50 reduction in cost per inference in a lot of cases. And you get to tap into the innovation and scale without any upfront investment and having to buy expensive GPU-based hardware. So we really see this as a significant step towards delivering on our vision to help machine learning become more accessible and more cost-effective to all types of customers. And it really is a broad set of supported use cases that we've seen using Inferentia so far. So from object detection, image classification, natural language processing, search, fraud detection. Customers really looking to increase their ML application performance and reduce the cost of running these models in production. And we really fully expect that as this cost is brought down, there's going to be use cases that come here that we haven't even thought of yet. So we're really excited to see where this goes. The last piece before we get to EKS that I want to cover is AWS Neuron. And AWS Neuron is the SDK that provides the tools and drivers to deploy Inferentia accelerated inference applications. It's designed from the ground up to allow for scalability, for high throughput and low latency for a wide variety of use cases. And the AWS Neuron has 3 components into it. It has the compiler, ahead of time compiler that you run your trained model through. It has the runtime, and then it has different profiling tools. And Neuron is integrated into all of the major frameworks. So TensorFlow, PyTorch, MXNet. We have Neuron optimized versions of these that you can install in your applications. If you already run applications through one of these frameworks, whether on CPU or GPU, it's a familiar environment to accelerate your applications with Neuron. A couple other things to note here is that the Neuron SDK is an open source project on GitHub, so you can go check it out there. We also have the Neuron support forum where you can get questions asked and have question is answered. So either of these are good places where to go learn about Neuron in the SDK. Another thing that I really find super exciting is a public roadmap. So the containers organization, some of you may be familiar with, we open sourced our roadmap around 2 years ago now, and it's really been a great success where customers can go see what we're working on, and we can interactions with the product team and the engineering team and customers. And so we've started to see a lot of other AWS services take this approach, which is super exciting. And the AWS Neuron roadmap is available on GitHub. It provides visibility into what the team is working on in terms of functionality and performance improvements. And we hope this will help you better plan how to use Neuron with your applications. There's constantly work to add new features, improve performance, and so you can go see what's coming, what's just completed, and what we're working on. So now let's talk about using Inferentia with EKS, because a lot of customers we see have standardized on Kubernetes as their compute platform, and they're running their microservice-based applications there in addition to their machine learning-based applications. And so with this single unified compute platform, you don't want to have to use EC2 instances just to run your machine learning while you're using Kubernetes to do your more microservice. So to make Inferentia work with EKS, we had to do three things. We had to build a Kubernetes device plugin. We had to build a containerized runtime driver. And we had to update the EKS optimized AMI for accelerated use cases to include the Neuron runtime. So let's cover each of these cases. We used to have what we called the EKS optimized GPU AMI, which was built specifically for GPU use cases. So the P3 and G4 instances, you could run this AMI for your applications, and it came automatically packaged with all of the drivers you needed to run machine learning applications. And so rather than release another AMI, what we decided to do is build on top of that existing GPU AMI, which is now, so we renamed it to the EKS Optimized Accelerated AMI. And it covers both Inferentia and GPU-based use cases. So the AMI, like it had before, it has the NVIDIA drivers in the runtime, and now it has the Neuron runtime. And when you launch an application, the AMI will figure out, it's smart enough to figure out what type of instance it's running on, and it'll load the correct runtime. So it's built on top of Amazon Linux 2. It includes the latest version of Docker and the kubelet to match the EKS control plane. The other important thing is Inferentia requires huge pages memory to make sure that your inference application is loaded into memory for faster performance, and that comes built in out of the box as well. So we strongly recommend to use this AMI if you want to use Inferentia. The next piece is a Kubernetes device plugin. So if you've used GPUs in your applications for either training or inferencing, there's a good chance you're installing the GPU device plugin into your cluster. And what device plugins in Kubernetes do is they can look and see what a specific resource that's available on the instance, figure out what's there, and then advertise it to the scheduler. And then in your Kubernetes applications, you can request those instances. So in the GPU case, you would request, I want one NVIDIA GPU in this that my applications needs to use. So it's a similar use case for Inferentia, where we have the device plugin where we're going to automatically advertise these Neuron resources to the Kubernetes scheduler. So it's something you can install in your cluster. If you happen to use EKS Cuddle, our command line, our open source command line tool, to launch Inf1 instances in your cluster, we will automatically install the device plugin for you. So it's not something you have to do. To check if it's working correctly, you can describe one of your Inferentia nodes using this command showed here, and you'll see that has the huge pages which are advertised, as well as the Neuron device. So in this case, we have a single Neuron device running on our instance, and we'll be able to request that in our application. And then the third piece I mentioned, which is the runtime driver. In the case of GPUs in NVIDIA, the driver is built into the AMI itself. But we took a slightly different approach with Inferentia, where it's a user space driver that's containerized, and you actually run it as a sidecar to your application. So if you look this, and I'll show a more full example in a minute, but if you look at this deployment file, we can see there's a second image, a sidecar image we're going to run next to our application. And it's this Neuron runtime driver. And you can see this is where you actually request the Neuron and the huge pages. So you just have to replace your ML serving container with a Neuron optimized version such as Neuron TensorFlow, and then you add your sidecar container to your deployment. So what I mentioned before, the Neuron optimized deep learning libraries like TensorFlow, PyTorch, and MXNet, you'll take one of those applications and you'll take one of those containers. You take one of those applications, push it to a container, and then reference that in your deployment. Coming soon, those will be part of the AWS deep learning containers, so it's not something you'll need to do yourself. For now, you can download the Neuron optimized version and use it in your application. So putting it all together, if you have an existing machine learning inferencing application running on Kubernetes, whether it's your own cluster or you're using EKS, these are the steps in order that you need to take. So the first thing you need to do is compile your trained model using AWS Neuron. So you take the model that you've already trained, you run it through the Neuron compiler, and then as a best practice, you push it to S3, because a lot of these deep learning libraries are already natively integrated with S3. The next thing you're going to do is launch Inf1 instances in your cluster. You can do that using whatever tools you're using today to manage nodes in your cluster. If you're using EKS Cuddle, that'll automatically install the Kubernetes device plugin. If not, it's something you can just apply as a manifest to your cluster. It's open sourced on GitHub. The next step is you may have an existing deployment where you're, say it's running on a G4 and this is your inferencing application. To that existing deployment, you're going to add this additional Neuron runtime sidecar container, and that's where you'll request your Neuron devices using that are advertised by the device plugin, as well as where you're going to request the huge pages of memory that are required. And then the last piece that I've mentioned is updating deployment to use the Neuron model. So you're going to point to the model that you push to S3 in step 1, and then you're going to swap out your serving image. So you may be using TensorFlow serving today, and you just need to swap it out for the Neuron optimized version of TensorFlow serving. And that's it. You deploy to your cluster, serve inferences at scale, and save money. So where to learn more? A couple of places. In the EKS documentation, we have a page dedicated to how to run Inferentia in your EKS cluster. We also recommend taking a look at the documentation page on the accelerated AMI, given that that's changed slightly from the GPU AMI. It's worth noting if you are using GPU and you're happy doing that, you can continue to use the accelerated AMI. It's completely backwards compatible. The next piece is the Neuron container tools, and this is in the open source Neuron SDK GitHub repository that was referenced earlier. And then the last page there is, this is in the AWS documentation, but it has more instructions on how you can compile models that are optimized for Inferentia using AWS Neuron. So that's it. We're really excited to see how customers can take advantage of this high performance, low cost inferencing solution on Kubernetes. And if you have any questions or suggestions, feel free to leave them in the chat. We'll be sticking around for a little while, or you can visit our virtual booth during KubeCon EU 2020. Thank you.